Hi, this is the second video that we are going to talk also still about refraction. And like in the previous video, I did show you that this is, let's say, the boundary between two media, air and let's say glass. Always we need to draw what is called the normal. And then here I will say this is theta I, which is the angle of incidence or the incident angle. And then if we are moving from air to glass, the angle here will be less. This is the angle of refraction, sorry. And if we have the opposite, what's gonna happen is that the angle is gonna get bigger. Then this is if this is glass and this is air. I will say air has an n equals 1, the index of refraction, and the glass has 1.53. Then when we move to low to high, this means that we are going to get the refraction will be away from the normal, sorry, towards the normal. And if it's gonna be from n equals 1.53 to n equals 1, that is gonna be from high to low and is gonna be away from the normal. Always the angles, they're gonna be measured from, the angles will be measured from the, the normal. All right. Now there is a law called Snell's law. It's gonna say n1 sine theta 1 should equals n2 sine theta 2. This is connecting, okay, this is, let's say, medium 1 and this is medium 2. Then it is connecting the indices of refraction with the angles. We use it either to calculate the angles or to calculate indices of refraction. And I will show you how we are going to use these. One more thing we need to study here is the total internal reflection. There is an angle, theta C, we call it the critical angle, and that is gonna make the light that is coming refract with 90 degrees. This happens only if the light is moving from a higher index of refraction to a lower index of refraction. Means from, let's say, glass to air, or from water to air, or from glass to water, okay? And that is really cannot happen if light from moving from air to glass. When theta I equals theta C, which is the critical angle, we know that the angle of refraction is going to be 90. And based on this, we can apply Snell's law. N1 sine theta 1 equals N2 sine theta 2. And we can say N1 sine the critical angle equals 1 times sine 90. Sine 90 is 1. And therefore, we can use this relationship to calculate what is really the critical angle of the substance. This is when the second medium is air. this one is more general. Then sine theta c is going to be always n2 divided by n1. Let me share with you the simulation again, just to show you what does it mean, the critical angle. Now, I said it's going to happen only if we have glass to air, like from high index of refraction to low. Now look here, as I am increasing the angle, what's gonna happen? There is an angle that is gonna make, look here, this one, like it has the refraction 90. After that, any angle above the critical angle, we're gonna have the light will be reflected. There is no, look here, if we can see here, like, just let me show you the meter. Okay, I have most of the light is gonna be refracted, 90.89, and always we should have like a small maybe portion of the light that is gonna be reflected. And I will say whenever we're gonna have the total internal reflection, 100 will be reflected, nothing will go through. This is called total internal reflection. Happens when the light is going to be incident with an angle more than the critical angle. For glass, it's about like 43, and then therefore this angle is going to be above the critical angle, and therefore is going to have the total internal reflection. Now let's do some stuff in here. Show that when the angle reflects from two mirrors that meet each other at a right angle, the outgoing ray is parallel to the incoming ray, as illustrated in the following figure. Here we have two mirrors. They have 90 degrees between them. Now the light, this is the one that is incident. And then we know that the law of reflection, theta 1 should equal theta 1 here. Like if this is going to be 50, is going to reflect with 50. This angle here, I'm pointing to, it is 90 minus theta 1. And that one is 90. Therefore, this one should be theta 1, and that one is going to be theta 2, and then it will reflect with theta 2. Again, for the second reflection, theta 2 equals theta 2, and we're going to know that each one should be 45, and therefore we're going to find that the two lights here, they are going to be parallel to each other. Now the law of refraction, we said we have either n equals c over v, or we can also have n1 sine theta 1 equals n2 sine theta 2. We use these for refraction. What is the speed of light in water or in glycerin? Okay, V equals C over V. This is from the table in your textbook where we have the indices of refraction, and it is for N for water, it is 1.33. Therefore, we divide here, we want to have V, then V, it is C over N, and we will be able to calculate this as 2.25 10 to the 8. This is using Snell's law. Find the index of refraction for medium 2 in the following diagram, assuming medium 1 is air, and given the incident angle is 30 and the angle of refraction is 22. Here simply we use what is called Snell's law. N1 sine theta 1 equals N2 sine theta 2, and N2 is going to be N1 sine theta 1 over sine theta 2. N1 for air, it is 1. sine 30 divided by sine 22, and then this is 1.33 for medium 2, and then medium 2, it is water. Here, more like problems like using also, remember we are talking about geometric optics, then like we are using a lot of geometry in this. A scuba diver training in a pool looks at his instructor as shown in the figure. What angle does the ray from the instructor's face make with the perpendicular to the water at the point where the ray enters? The angle between the ray in the water and the perpendicular to the water is 25. What we can do simply is n1 sine theta 1 equals n2 sine theta 2. And then what we can do is we want to have sine theta 1. We want to have theta 1. Let me like just clarify this equation here. N1 sine theta 1 equals N2 sine theta 2. I want to have sine theta 1 here, and therefore this is going to be N2 over N1 times sine theta 2, and then theta 1 is going to be sine inverse N2 over N1 sine theta 2. You are going to plug in the numbers into your calculator, like here 1.333 over 1 times sine 25. Find sine 25 multiplied by 1.333 divided by 1, and then have the second function sine, and that is gonna give you what is theta 1, and it is 34.3. One more thing here is here we have 3 media. Then the first medium has N1, and this is N2, and this is N3. Shows a ray of light passing from one medium into a second and then to a third. Show that theta 3 is the same as it would if the second medium were not present, providing total internal reflection does not occur. We are going to apply Snell's law at each interface. Interface means it's the boundary between the two media. This is medium 1, this is medium 2, and this is medium 3. N1 sine theta 1 should equal N2 sine theta 2, and then N2 sine theta 2 should equals N3 sine theta 3. Now remember, this one is exactly the same as this one, then I can say that N1 sine theta 1 equals N3 sine theta 3, and then it's going to be the same like I did before with the previous question. This is the critical angle and the total internal reflection. The incident angle here, theta 1, it is the angle that is going to produce an angle of refraction that is called, that angle is going to be the angle of incidence. We call it the critical angle, is going to create a 90 degrees refraction angle. Now dispersion, it is because of the refraction and because every color of light has a different index of refraction in glass. Therefore, then the white color light is gonna be splitting into all its components, and that is forming the rainbow. Then when we have the white light moving in air, all the lights, they are going to move with speed of light, and they will be mixed, and they're gonna form the white light. What's gonna happen when they are going to be going into glass or droplets of water? They will split separately, and they will move with different speeds, and therefore we're gonna see the separate colors. Okay, I'm gonna stop here, and then I'm gonna see you in another video. Thank you.